Previously, when discussing how we should define the intersection number of a map F, right, from a manifold M to a manifold N, with an embedded submanifold Z of N, we raised the following question. Suppose F is not transversal to Z. Could we deform F? Could we wiggle it a little bit so that it becomes transversal to Z? More formally, does there exist a map G homotopic to F such that G is transversal to Z? The answer turns out to be yes. And that is the content of the transversality homotopy theorem. In this video, we're gonna discuss the general ideas of the proof of this theorem, and then we'll fill in the details in subsequent videos. This way, all of the theorems that we introduce are gonna be motivated. We can see why we need them by seeing how they play out in this proof. Alright, so let's discuss the general idea of the proof. The first step of the proof is to extend the map F to a family of map such that this whole family is transversal to Z. What do we mean by a family of map? Well, we can take some smooth manifold S, and a smooth family of maps from M to N parametrized by S is just a smooth map on S times M. Observe that for every little s here in S, we have a copy of M. And if we restrict this big F to that copy, i.e. if we look at this function, then we can view this as a map from M into N. We will denote the map at level S by this. Thus, we have a family of map from M into N, right, parametrized by S. Alright, so step 1 of the proof is to show that there exists such a family, right? We can extend this little f to a family big F in such a way that big F is transversal to Z. Now, in step 2, we're going to show that any two maps in this family are going to be homotopic. That is, assuming that S is connected. Finally, we will show that at least one map in this family is going to be transversal to Z. Now then, because of step 2, we know that any such member must be homotopic to this little f, and thus we have proven that F must be homotopic to some map that is transversal to Z. Actually, in step 3, we'll prove something even stronger. We will prove that actually most of the map, almost all of the map in this family, are gonna be transversal to Z. That is gonna be the content of the parametric transversality theorem. In the next video, we're gonna start with step 1. To construct this family, we will need to be able to construct a tubular neighborhood of N. And for that, we'll need to be able to embed N inside some Euclidean space, so we will need Whitney embedding. Thus, we'll introduce all of these in the next video.